Okay, so you should have done some research online and been able to define the terms that you see here. And then I'm going to put the answers up and just have you check your answers. Okay, so you can pause this if you want. You already found definitions that you might like better or have written them in your own words, so you can use that. I just want to point out a couple of things. So a polynomial is just a function, is just an expression made up of many terms, and those terms can have numbers and variables. A monomial specifically means it only has one term. And when we look at degree, if it's a monomial, it's the only degree that's there, the Pegas power. When it's a polynomial, you have multiple terms that have multiple degrees, but you choose the degree of the highest degree term. And then we'll talk more about end behavior and turning points. You should have graphed these on Desmos to get an idea of how they behave. I'm going to sketch them, and they're not going to be perfect, but you should generally have the same shape. So here is your constant. Then you had a line with a positive slope, a quadratic, a cubic, a quartic, and a quintic, a function of degree 5. So again, these aren't perfect. You have more exact sketches from your Desmos, but their behavior was something like this. And we're going to use this to talk about patterns that we should see. So the first pattern you should see is that anything that has odd degree, so notice this is degree 1, degree 3, degree 5, that their graph ends in different directions on the left and right side. Notice that one end's always going down towards negative infinity and one end's always going up towards positive infinity. Whereas the functions with even degrees, here degree 2 and degree 4, you see their functions going the same directions at that end. Okay. The other patterns that you should see here is that the amount of times the function turns around can vary. Like it looks like here in the quartic that it only turns around once, but it does have this like weird curve somewhere else. But then in the quintic, the degree 5 function, you see it turn around 4 times. So basically, the number of turning points is equal to maximum 1 less than the degree. So it doesn't have to be that many, but it can. So like in the quartic, you didn't see it turn around as many times, but you saw that it could turn around different amounts. Okay. And then you should also notice that the number of zeros, the maximum amount of times it can cross the x-axis, is equal to the degree. Like it might not, like again, the quartic doesn't cross 4 times, but like the cubic does, and then your quintic can cross up to 5 times. But because it can't turn around another time, it can never exceed that maximum amount on its degree. So we're going to try and take these ideas and apply them to generally be able to identify the behavior of these kinds of functions. So first skill here is just basically naming, okay? And so here's a polynomial. We want to write it in standard form, and that just means combine like terms and put the highest powered term first. So it would look like this. So naming the polynomial based on its degree, the highest term with degree is with degree 3. And so this would be the highest degree of 3, which we call a cubic. Once it gets over a quintic, you can just say like of degree 6, and then name the polynomial based on its number of terms. This polynomial has 4 terms. So we say monomial, binomial, trinomial, and once it gets past 3 terms, we just say a polynomial. And then you can list how many terms it has if that's necessary. Okay. So then we're just going to do a couple more like based on the shape of the function and talk about end behavior. That's something we're going to have to add into your notes. So here we're looking at degree, if it's even or odd. Now really keep in mind we're talking about degree because you'll talk about some other things later in pre-calc, and then how many real zeros it has. So this first one in part A, I see it cross the x-axis or hit the x-axis 3 times. So it has 3 zeros. And then because the ends go in the same direction, it would be of an even degree. For part B, I see the ends going in the same direction again, so it's even degree. But notice it never comes down low enough to hit the x-axis, so there are no zeros. And then for part C, the end behaviors go in different directions, so this would have to be an odd degree function. And I see it hitting the x-axis twice. Okay. All right, so then we're going to estimate turning points. So in the first graph, I'm going to mark these in a different color. So in the first graph, I see a turning point here. I'm going to call that negative 2.2, and then 1, 2, 3, 4, negative 4.5. And then we have another turning point here, which looks like it's 0.5, 2.5. Again, I'm estimating. And we have a turning point here that looks like it's at about 3.0 on the graph. For this other second graph, we have a turning point here at negative 3.5, 1.5. We have a turning point here at what looks like 4.8, and another turning point here, which looks like at about 0.5. And then on this last graph, we have a turning point here, which looks like about 1.5, and then one here that looks like 3.50. Okay, and then increasing, decreasing intervals now, there's just more because the graph turns around one time. So I'm going to do it for one of these, but not for the other ones. I'm going to do it for the first one. So we're going to focus just on part A, and then I'm going to talk about end behavior for you. So for the graph in part A, this first portion of the graph is decreasing, and then it's decreasing again over here. And then I'm going to highlight the increasing parts in red. So this portion's increasing, and this is increasing. So when you go to write your increasing intervals, remember we use x values. So the x value associated with this point right here was negative 2.2. The x value associated with this point up here was 0.5 and then 3. So for the increasing intervals, it's from negative 2.2 of an x value to 0.5. And then there's another interval from 3 to infinity. And because there's two of them, we put this union sign in between them. We just write both intervals with this u between them. And then the decreasing interval that we see is from negative infinity till negative 2.2. And then there's another one, so I'm going to put this u between them. And then that's from 0.5 until 3. And so you could list as many intervals as you want that way. Okay. The last thing we're going to talk about is end behavior. And then we're going to add this to our notes. And then I just want you to notice, so I'm going to focus first on part C. Notice that this end goes up towards infinity, where this end goes down towards negative infinity. The hardest part here is that you're going to have to learn some notation. We're not going to say left and right. What we want to say, what we're thinking in our head, is that the left side goes to negative infinity and the right side goes to positive infinity, but that's not the mathematically correct way to say it. So what we're going to say is we're going to say as x goes to negative infinity, that tells me you're on the left. F of x goes to negative infinity, that tells me you're going down. And as x goes to positive infinity, that means you're on the right. F of x goes to positive infinity. So your end behavior needs to be written like this. So you're going to make sure you include that. Your book answers won't say that, but you're expected in this course to use this notation. So just try and practice that.